Time travel is one of those tantalizing concepts that has haunted the human imagination for centuries. Who hasn't dreamt of fixing a past mistake or peeking into the future to see if humanity finally invents self-folding laundry? In this year, the science of time travel is still a mix of theoretical brilliance, wild paradoxes, and let's face it, the stuff that keeps sci-fi writers in business. So, strap in as we dive into the exhilarating possibilities and brain-twisting paradoxes of time travel, armed with the latest science. No DeLoreans required. The basics of time travel. What does 2024 know? Time travel is no longer just the realm of science fiction. Thanks to advancements in quantum mechanics and general relativity, scientists are uncovering more about how time operates. The fundamental concept that allows for time travel is our understanding of space-time, the fabric that blends time with the three dimensions of space. According to the most recent studies, time travel might not only be theoretically possible, but could also occur without breaking the universe as we know it. Scientists in this year are particularly focused on how time can be bent or manipulated in ways that could make time travel a reality, with groundbreaking research happening in laboratories around the world. Although we are still far from building an actual time machine, our increasing knowledge about time is setting the stage for future possibilities. Paradox-free time travel. Is it possible? The key to making time travel feasible lies in resolving the infamous paradoxes such as the grandfather paradox. The grandfather paradox presents a scenario where a time traveler could go back in time and prevent their own existence by, for example, stopping their grandparents from meeting. Physicists have explored models that allow for paradox-free time travel by proposing that alternate timelines could emerge. Imagine stepping into a time machine, only to find that the past has shifted slightly, creating an alternate timeline where all your paradox-causing antics are safely contained. This solution does not break the universe. It just bends it into a new reality where both outcomes can coexist without causing any contradictions. While this theory is still being refined, it opens the door to a version of time travel that does not unravel the fabric of reality. Parallel timelines, the ultimate loophole. If paradoxes cannot be avoided entirely, then parallel timelines may offer a solution to the problem. In this model, every action a time traveler takes results in the creation of a new alternate timeline. This means that whatever changes you make in the past, they only affect this newly created timeline, not the original one. So go ahead, warn your younger self not to get that questionable haircut in middle school. Just do not expect the you in your original timeline to benefit from the change. This theory of parallel timelines is becoming increasingly popular as scientists explore the idea that if time travel is possible, it will likely involve hopping between these coexisting parallel worlds. This concept is often seen in science fiction, but now physicists are working on ways to make it a viable explanation for how time travel could function in the real world. Quantum mechanics. Schrödinger's time traveler? Quantum mechanics often feels like a game of cat and mouse, or perhaps cat and no cat, if Schrödinger is involved. In this year, some researchers propose that time travel could be explained by quantum superposition, a phenomenon where particles exist in multiple states simultaneously. This means that a time traveler could theoretically exist in both the past and the future at the same time, creating a scenario where they are both influencing and being influenced by events in different moments. It is like being both the hero and the villain of your own story, just do not expect it to make for a coherent autobiography. The possibilities here are as mind-bending as they are exciting, as scientists continue to explore the strange and unpredictable world of quantum mechanics and how it might one day allow us to move through time. The energy problem. A light speed barrier? Here is the catch. Even if time travel is theoretically possible, the energy required to pull it off is astronomical. Some scientists suggest that to travel back in time, you would need an object with infinite mass or energy, which is, unfortunately, as real as a unicorn made of dark matter. To put it in perspective, the amount of energy needed to bend space-time enough for time travel would likely surpass anything humanity could ever harness with current technology. And while traveling forward in time might be within the realm of possibility, zipping back to say hello to the dinosaurs or preventing your worst fashion faux pas is going to require a bit more than just a fully charged smartphone. In this year, researchers are still grappling with how to overcome these immense energy requirements, which remains one of the biggest hurdles in the pursuit of time travel. Wormholes, nature's time tunnels. Speaking of shortcuts, wormholes might offer a more practical way to traverse time. Wormholes are hypothetical passages through space-time that could allow for instant travel between distant points in time and space, much like a tunnel that connects two separate locations. These cosmic shortcuts could theoretically enable time travel, but do not pack your bags just yet. Wormholes are as tricky as they sound. Keeping one stable long enough to use it for time travel would require negative energy, a mysterious form of energy that scientists have not yet figured out how to create or sustain. Despite the challenges, wormholes remain one of the most fascinating possibilities for time travel, with researchers continuing to investigate whether they could one day serve as nature's own time machines. The Novikov self-consistency principle. The universe protects itself. The Novikov self-consistency principle suggests that the universe has built-in safeguards to prevent paradoxes from occurring. According to this principle, even if time travel were possible, you would not be able to change events in a way that would create a paradox. For example, if you traveled back in time to stop an event from happening, such as saving the Titanic from sinking, you would somehow fail, because the outcome has already been determined in the timeline from which you came. This theory is like the universe's way of saying, "Nice try, but I have got this covered," ensuring that time remains consistent and unchangeable. While this principle offers a comforting solution to the paradox problem, it also limits the freedom that most people associate with the idea of time travel. In this year, scientists are still debating whether the Novikov principle is a fundamental law of the universe or just a clever workaround. The future of time travel research. What is next? As of this year, time travel remains a tantalizing possibility, but it also comes with a hefty set of challenges. Future research is likely to focus on quantum mechanics and general relativity, especially in resolving the paradoxes that threaten to unravel the whole idea of time travel. Physicists are also exploring exotic matter, negative energy, and other theoretical concepts that could make time travel more than just a speculative endeavor. The road ahead is long and uncertain, but with each passing year, we are getting closer to unlocking the mysteries of time itself. Whether or not we will ever achieve time travel remains to be seen, but one thing is certain: scientific curiosity will continue to push the boundaries of what we know. Fiction versus reality. Will we ever see a time machine? From H.G. Wells' The Time Machine to Avengers: Endgame, time travel has been a favorite subject for storytellers for generations. But while fiction can gloss over the messy details, real science is not as forgiving. In reality, creating a working time machine is like trying to knit a sweater with spaghetti. It is theoretically possible, but highly impractical. The complexities of time travel involve so many unknowns and theoretical hurdles that we may be centuries away from ever making it a reality. That said, every year brings us closer to understanding the mysteries of time. So who knows what the future holds? Maybe we will find out when someone from 3024 drops by for coffee, or maybe that someone will be you, returning from the future. That's all for today's video. If you enjoyed this deep dive into the science of time travel and all its mind-bending possibilities, do not forget to give this video a thumbs up and subscribe to the channel for more exciting content. Until next time, keep dreaming big and stay curious.